Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In the previous video we learned question number 4 related with exercise number 9.1 related with chapter number 9 differential equation related with the particular and general solution with related with FSC part 2 mathematics. In today's video I will solve the last question of the same exercise number 9.1 question number 5. It is related with the initial value problem. So let's move toward lecture number 5. Differential equation, chapter number 9, FSC part 2 mathematics, exercise number 9.1. This is the last question, question number 5. Solve the following initial value problem. So what is initial value problem? So if we have a differential equation is given and the differential equation is dependent upon an unknown function in term of two variables, just like in these two questions, variable y and x is used. So for finding the particular solution of this differential equation, for first finding the arbitrary constant c, so the required solution and the required condition is initial condition, and the related differential equation is called initial value problem. So let's move toward part number 8. dy by dx is equal to cos of x, while the condition is y of 0 is equal to 1. So this is actually the initial condition. In this initial condition, this is the input value x and this is the required output value, which is the range and which is actually our y. So first we are going to find the solution to this differential equation. So shift dx on the right hand side, it become dy is equal to cos of x into dx. Now integrate both sides. So over here integral of dy is y and the integral of cos x is sin x, and it become plus constant of integration. Now putting the value of y is 1, so by putting 1 and over here x is 0, so it becomes sin time of 0 plus c. So over here sin 0 is 0, so it is equal to 1 is equal to 0 plus c, so the required value of c is 1. So the particular solution will be putting the value of c is equal to 1 over here in the general solution, so y will be equal to sin time of x and plus c is 1. This is the required particular solution for this initial value problem, and this is very important. This MCQs came in the previous ETA paper. Now let's solve this part also. Shift dx on the right hand side, so it becomes dy is equal to x square into dx. So now integrate it. So integral of dy is y and integral of x square is x power 3 divided by 3 and plus constant of integration. Now the value of x is 0 and the value of y is 1. So putting over here y 1, so it become 1 is equal to x cube by 3. X is 0, so this whole term will be 0, so we left with just c. So my c is 1. Now by inserting c over here, it will give us the required particular solution for the initial value problem, x power 3 divided by 3 and plus c. C is actually 1. This is the required solution. Now let's understand the next part, part number c. It tells that dy by dx is equal to 2xy square, while the condition is y of 3 is equal to negative 1. So this input value is actually x value and this is the required range, which is actually the value of y. So first taking the differential equation, dy over dx is equal to 2xy square. So we will solve this type of differential equation through separable differential equation. In separable differential equation, we shift the value of x and the differential dx on one side and the value of y on the another side. So over here we have dy, so shift this y square to this side. So over here it is in multiplication, so by shifting to the left hand side, it will move to the denominator. In division, it becomes dy over y square. And shift dx on the right hand side, it will multiply with 2x, so it becomes 2x dx. Now integrating both sides. So y square will move to the numerator, it become y power negative 2 into dy integral, and over here 2 will be written outside of the integral, inside we left with x dx. So y power negative 2, so by applying the generalized power rule, so we will add 1 in the power, so minus 2 plus 1, and write the same power in denominator, minus 2 plus 1 is equal to 2 times up. Over here the x power is 1, so using power rule, so add 1 in the power, so 1 plus 1, and using the same power in the denominator and plus constant of integration, so it become y power negative 1 and it become minus 1 and it become 2x power 2 divided by 1 plus 1 is 2 and plus a constant, so they cancel out with each other. So by simplification, it become minus time of this minus will move to the numerator and y power negative 1 will move to the denominator, it become 1 over y. And over here we left with x square plus a constant c. Now the value of y is minus 1, so put over here, so it become minus 1 over minus 1 is equal to x square. X is 3, so it become 3 square plus a c. So over here we left with 1 is equal to 3 square gives us 9 and plus c. So the required value of c will be 1 minus 9, which is negative 8. Now by inserting the value of c is equal to negative weight over here, it become minus 1 over y is equal to x square plus c. So x square plus c is minus 8. Now reciprocating both sides, so it become minus time of y is equal to, it become 1 over x square minus 8. So the required value of y will be, shift minus on the right hand side, so it will be minus 1 over x square minus 8. So over here minus 1 over y is equal to x square plus c is minus 8. So y minus y is equal to 1 over x square minus 8 and y is equal to minus 1 over x square minus 8. Further, this minus will move to the denominator, it become y is equal to 1 over 8 minus x square. So because minus minus plus 8 and over here minus will multiply, so it become minus x square. So this is the required particular solution. Now let's understand part number D, which is little bit difficult as compared to other part of this question number 5. dy by dx plus y is equal to y square while the condition is y of 0 is equal to 1 over 2. Move to solution. Shift y on the right hand side, it become y square minus y is equal to dy by dx. Shift y square minus y on the left hand side, it will move to the denominator. So y square minus y into dy, and shift dx on the right hand side and take the integral. So over here y square minus y, take out y common, we left with y minus y dy is equal to dx. Let's suppose this is equation A. So over here I will use the partial fraction method for finding this integral. So 1 over y into y minus 1. So over here y is a linear factor, I will take single constant a over y. Y minus 1 is a linear factor, I will take another constant b over y minus 1 whole dy. So over here y into y minus 1, and in the numerator we have 1, and over here take LCM y into y minus 1. So over here we left with a into y minus 1 and plus b into y. So these are cancelled out on both sides. So we left with 1 is equal to ay minus a plus by. Let's suppose this equation C. From over here y is equal to 0. So put y 0 over here, it gives us a is equal to negative 1. From over here my y minus 1 is equal to 0. So y is equal to 1. Put in this equation. So it will give us the required value of b is equal to 1. Now putting a b over here. So a is minus 1. So minus 1 over y. B is 1. So 1 over y minus 1 and integrating. So it is actually the value of dy over y into y minus 1. So by integration it become minus ln of y, it become ln of y minus 1 and integral of dx. Over here integral of dx is x plus c. So it become, put x is equal to 0. This is the value of x and this is the value of y. So putting x and y over here, so it will give us the required value of c minus 2 ln of 1 over 2. Now by putting the value of c in this equation, so minus ln of y plus ln of y minus 1 can be written in this form according to the generalized formula of logarithm. And x plus c, x will come down here it is, and c is minus 2 ln of 1 over 2. Now take exponential on the both side. So over here they are cancelled with each because these are the opposite of each other. So y minus 1 over y and e power x minus 2 ln of 1 minus ln of 2. Ln of 1 is 0. So it become x plus 2 ln of 2 and exponential. So it become 1 over 1 minus 1 over y exponential x plus 2 ln of 2. 1 minus 1 over y exponential e power x into e power 2 ln of 2, because this is the product rule. So we know that a power m dot n can be written as a power m plus n. Over here m plus n can be written as a power m into a power n. So a power m into a power n. So 1 minus 1 over y e power x. Over here this 2 will move to the power, so it become 2 square, which gives us 4 and e ln, and it will become 4 and e power x. So 1 minus 1 over y, this will cancel out with each other. We left with 4 into e power x into 1 over 1 minus 1 over y. So from over here we will get the value of y is equal to 1 over 1 minus 4 e power x. This is the required particular solution to this part number D. Now let's understand the last part number A of question number 5. Simplify part number 5 of this question yourself. So let's solve the last part number A. 2 dy over dx is equal to 4x e power negative x while the condition is y of 0 is equal to 42. So over here this 4 and 2 they will cancel out with each other. So 4 over 2 gives us 2x e power negative x and dy by dx comes down as it is. Now shift dx on this side, so it become 2 times of integral of x e power negative x into dx, and over here integral of dy. Now over here we have two functions using integration by part. First function and this is second. So integral of dy is y. Over here 2 will take out common. So first function integral of the second minus integral derivative of the first function integral of the second whole dx plus constant of integration. So x e power negative x integration is e power negative x over negative 1 minus integral derivative of x is 1. Integral of e power negative x is e power negative x over negative 1 and plus constant c. So 2 times of it become minus x e power negative x minus plus integral of e power negative x dx plus c. So it become minus 2x e power negative x and plus 2 times of integral of e power negative x is e power negative x over negative 1 plus c. So y is equal to minus 2x e power negative x minus 2 e power negative x plus c. Now the value of x is actually 0 and the value of y is 42. So putting x0 and y 42 over here, it will give us the required value of c is equal to 44. So putting the value of c over here, so minus 2x e power negative x minus 2 e power negative x, and c is 44, so plus 44. This is actually the required particular solution for this initial value problem. So with this question I finish my lecture. Inshallah, in the next video I will start the next exercise, which is the last exercise of chapter number 9, exercise number 9.2. So thank you for watching, subscribe my channel, and also hit the bell icon to receive the upcoming notification and interesting problems related with mathematics. Thank you.